the imminent collapse of Betelgeuse is uncertain. It is unquestionable that the gigantic star will eventually leave the cosmic stage in a brutal explosion, but according to some researchers, this elementary event could occur much sooner than expected. But what does this mean for us? Will the colossal cosmic explosion also plunge our Earth into confusion? And why does the star in the shoulder of Orion currently exhibit behavior that is puzzling astronomers? The Sun, in our daily lives, often embodies the cosmic measure that no other celestial body can match. When it comes to our home system, this is indeed true. With a diameter of no less than 1.4 million kilometers, the Sun easily surpasses all its planetary companions. In theory, the Earth could fit into the Sunday January 3rd million times. However, our central star has started shrinking more and more. When we compare it to other galactic giants, like Betelgeuse, the Sun is overshadowed in all imaginable astronomical aspects. In fact, the giant star known internationally as Betelgeuse has a diameter 800 times that of the Sun. In this heavenly body, the Sun would turn into a microscopic pinhead that would fit 500,000 times into the poles of Orion. The differences in brightness are equally extreme. Betelgeuse shines 10,000 times more brightly than our standard heat source. As a result, it is even possible to see this celestial body with the naked eye in the night sky, which is located about 650 light-years from Earth. If you find yourself in the northern hemisphere during the winter, it is virtually impossible to miss the supergiant red star. And not just since yesterday. In fact, Betelgeuse was already mentioned 2,000 years ago as a yellow-orange point of light in the sky. But like all other objects in the universe, Betelgeuse is not a fixed and unchanging object. On the contrary, measurements of its radius using interferometry have revealed that it fluctuates by about 15%. Interestingly, Betelgeuse's radius was the first to be determined using this method of measurement. These changes are by no means limited to its radius, they also affect its brightness. Thus, an apparent variation in brightness occurs every 2,070 days, a phenomenon that is primarily due to the advanced stage in which Betelgeuse currently resides. In principle, red supergiants have the characteristic of expanding and contracting again, with this pulsation being directly linked to changes in brightness. However, a few years ago, scientists were taken aback by the scale and complexity of this process. In an incomprehensible communication at the time, in October 2019, a process began that ultimately led to a dramatic decrease in luminosity by February 2020. At that time, it had dropped to less than 40% of its initial average value. Since the beginning of astronomical studies, Betelgeuse had never shone so faintly. After learning of this mysterious event, researchers immediately tried to decipher the reasons behind it. For some researchers, the loss of luminosity was simply the result of several overlapping luminosity cycles. Others, however, feared that the incident was the result of something much more dramatic, a supernova. In principle, the approach of a stellar explosion is typically announced by a significant expansion of the star and a considerable decrease in its brightness at the same time. However, since no star has been observed directly before a cosmic explosion, we do not know if such dimming occurs several years or only a few hours before the actual event. However, there is no doubt that Betelgeuse will eventually make a dangerous exit. According to the current state of knowledge, the red supergiant will, however, not meet its fate for a distant future, as it has only relatively recently reached its final stage. The cosmic explosion should therefore occur in a good 1.5 million years. However, other researchers have set a much tighter timeline and estimate that Betelgeuse will disappear from the celestial stage within the next 100,000 years. After Betelgeuse literally regained its glory in April 2020, scientists discovered the cause of the drastic drop in its luminosity. In August of the same year, data from the Hubble Space Telescope revealed that the star had ejected a huge cloud of hot and thick matter. This cloud then cooled, condensed into dust, and obscured the light emitted by the star. Due to the veil of cosmic dust, it seemed from our perspective on Earth that the star had considerably lost its luminosity. Now that an explanation for this past evolution has been found, it didn't take long for the star to present another mystery. Since 2023, Betelgeuse has been shining much more brightly than usual. What does this mean? When Betelgeuse explodes, will it happen soon, or in several thousand years? One thing is certain, As soon as the red supergiant turns into a cosmic explosion, the elementary powers at work in the universe will remind us once again in a stunning way. As mentioned, Betelgeuse already shines 10,000 times more brightly than the Sun, but researchers expect its luminosity to increase by 16,000 times during its stellar death. While some specialists assume that the star's brightness will then be almost identical to that of the crescent moon at night, others think it will resemble the brightness of the full moon. In any case, it would be impossible to miss the cosmic explosion from Earth. But what will this brutal event mean for our blue planet? Will Earth eventually be annihilated along with its stars? Fortunately, it is not as dramatic as it sounds. Fundamentally, the concern with such stars is that the gamma-ray explosion that will accompany the cosmic explosion could also affect Earth. In the case of Betelgeuse, however, specialists give the green light because the star's axis does not point in the direction of our home planet. The gamma-ray explosion will not be intense enough to negatively affect our planet. What is particularly exciting, however, is that there could even be two streaks after the star's explosion. The ejected material might collide with the surrounding shell of the supergiant at a certain distance, and this subsequent impact would also manifest as a blast that would be noticeable from our planet. But what will remain after this brutal explosion? Will Betelgeuse's former position now be adorned with a vast void? Most likely not. As is typical for stars of this size, the supernova should also give birth to a neutron star with a mass 20 times that of the Sun. Does Betelgeuse spin too fast? Neutron stars are particularly known for their unparalleled spinning speeds. In 2004, researchers even found one that spins 716 times on its axis in a single second. And while Betelgeuse is thought to be on track to become such a stellar remnant, its rotational behavior has already drawn the attention of astronomers in detail. Pictures taken by the radio telescopes of the ALMA Observatory suggest that Betelgeuse is rotating unusually fast. In fact, the star spins much faster than it should, with a speed exceeding 5 kilometers per second. Its rotational speed is about 50 times higher than what would be normal for a red supergiant. Generally, stars spin more slowly as they expand, and Betelgeuse is the only star of its kind known to be spinning this fast. But why is that? One of the possible explanations is that the star in Orion's shoulder literally swallowed another star. According to this hypothesis, it is conceivable that Betelgeuse might have incorporated a smaller star during its growth. Although this might seem quite crazy at first glance, it is not so strange, actually. We know that massive stars regularly interact with their nearby companions. In theory, stellar assimilation could have transferred the angular momentum of the swallowed star to the outer envelope of Betelgeuse, thus increasing its rotation speed. However, if we follow the explanations of Ingzema from the Max Planck Institute for Astrophysics in Garching, near Munich, things could actually be quite different. In fact, the surface of Betelgeuse is filled with gigantic plasma bubbles that rise and fall, what we call convection currents. This is where the problem lies. Scientists deduce the rotation speed based on the bipolar structure of the star's surface. Indeed, while one half of its visible surface shows a blue shift, the other shows a red shift of several kilometers per second. However, the movement of convection currents can also cause a red and blue shift in the radiation. If a very large convection bubble or a group of multiple convection bubbles moves towards the observer and another moves away, this can create what we call a bipolar velocity field. In this way, even a star that is not rotating could appear to rotate at a tremendous speed. However, further research is needed to determine how much this theory relates to reality. Scientists hope to resolve the mystery of the rotation using high-resolution ALMA images. A first series of observations has already been carried out, but the data is still being analyzed. We would be thrilled if you continued to follow the future developments of our observations in our videos. Don't hesitate to hit the like button and subscribe now to never miss another exciting video from us.